Hi everyone, in this video we'll be going through the answers to this gas chromatography database question. Right, in the previous video we have gone through the strategies, which is very important. Make sure you watch the strategies video on how to handle database question. So let's look at the answers. So the first one, describe a similarity between gas chromatography and fractional distillation. So firstly, we have no idea what gas chromatography is. However, when I read through a passage, I see that there's this thing that says how it works, right? And I've read that GC, gas chromatography, separates the components of a mixture based on the boiling points. So because I've applied the correct strategy, I really zoom in. Oh, I'm looking for something like fractional distillation, and this is my evidence. Okay, so how do I write my answer then? So what's the similarity? You must write both, right, GC and fractional distillation separates mixtures by boiling point. So you see, when you read the questions first, you really zoom in on the very important details in the passage and don't get distracted by other things that you don't understand the passage. Right? Now, next one, chemical N, pure substance. Explain your answer. So let's look at where N is. So the first time N is mentioned, you realize it's over here. So you see, all of this thing over here, I don't need to read yet. So I zoom in. Oh, N is here, right? So let's take a look. A sample of N was injected, right? Column temperature increased over 10 minutes, and then 4 substances were separated from N. Now, 4 substances were separated from N, and that means that chemical N is not only chemical N. There's actually 4 things over here. Can chemical N therefore be a pure substance? Right? So this is how you use the strategy answer. So the thing is that N is not pure substance. So because this is an explanation, you write since, NS, and therefore. And what we are trying to explain over here is that N is not a pure substance. So N is not a pure substance. So why is N not a pure substance? The direct reason why N is not a pure substance is because it's a mixture. So NaN is a mixture. And how do I know there's a mixture? The data over here shows that N contains A, B, C, and D. 4 substances. Since N contains 4 different substances. So because N contains 4 different substances and N is a mixture, therefore N is not a pure substance. Okay, let's look at the next question. Boiling point and retention time. So we can look over here. Let's look at these 2 graphs. So we need to look at this graph and we need to look at this boiling point. So we see there's this retention time here. And then we see A boiling point, B boiling point, C boiling point, D boiling point, and then there's different retention times. So if you look at A has the lowest boiling point, it has the lowest retention time. D has the highest boiling point, and it has the highest retention time. So what is the relationship? So the relationship is as, right? Something increases, the other thing increases. So as the boiling point increases, retention time increases. So that's how you write the relationship. As boiling point increases, retention time increases. Now, next question, I need to predict the retention time of ethylene glycol. So I'm looking at the relationship. Ethylene glycol is over here. Ethylene glycol has a boiling point of 195, which I can see that, it's in between B and C. Right? 195 is in between B and C. So I need a time that's around between B and C. So I think it's quite obvious I should use this number over here, right? 7. So my prediction is that it takes 7 minutes. Alright, okay, last question, which is slightly more difficult. I need to now explain why glycerin will not give any results. Okay, will not give any results. So over here, glycerin has a boiling point of 290. So that means it has a higher boiling point than D, and therefore the retention time should be somewhere around here. But that doesn't mean that there should not be any results. So we need to read a bit more. So let's see how it works. So according to GC, how it works here, the temperature of the GC column can be varied from 50 to 250 degrees Celsius. Then the components in the mixture must be vaporized so that it can flow, right? However, if you look over here, glycerin has a boiling point of 290, but the maximum temperature of the GC column is 250 degrees Celsius. So that means that glycerin is not vaporized because 250 degrees Celsius is still below the boiling point of glycerin. So, so what we need to do is that we need to explain why this is so. So since and as and then therefore. So therefore, glycerin shows no result. The reason why glycerin shows no result is because it is not vaporized. And as glycerin is not vaporized, but why is it not vaporized? Now, this is when you need to show some data. So since glycerin boiling point is 290 degrees Celsius, but the maximum temperature of the GC is 250 degrees Celsius. So since the glycerin boiling point is 290 degrees Celsius, but the maximum temperature of the GC is 250 degrees Celsius, and as the glycerin is not vaporized, therefore glycerin shows no result. Alright, so I hope that has been helpful for you. Please rewatch certain parts of the video if you still don't understand, and I'll see you in the next video. Alright, thank you.